Right, so we're going to look at some trigonometric graphs. So we're going to look at sin x, cos x, and tan x. So what I've drawn is the sin x graph. You should know that between angles 0 and 90 rises to 1. And then in your C2 you will have covered the fact that it's a cyclical graph, it's a wave, it just keeps go round and round and round a circle. And we see our sine graph traced like this. If we're given a question, find the angle that gives the ratio a half, and we're talking about the ratio between the opposite side and the hypotenuse, and that will come from a particular angle. Now, the graph, however, shows you that between 0 and 180 there are in fact two angles that you can put in, and that will give you the ratio a half. So I'm going to bring my calculator to the screen and show you what we would do. So we do sine minus 1.5 equals, and we've got the answer 30 degrees. Now, the calculator will not give me the other answer. So I'm just going to write in 30 degrees. So we have to know what the connections are. Now, because of the symmetry of the sine graph, the other angle will be 150 degrees. And the connection between the two angles is they add up to 180. Now, I'm going to show you them here and here. This is called the principal value, and this is called the secondary value. And if I were to continue the graph, you'd find that there's another solution here, and another solution here. So how would I find those? Well, we have a general formula for the equation sin x equals s, where s is some ratio between 1 and minus 1. It can't be larger than 1 or minus 1. So that value s comes in two parts. You take the principal value, and that's the value that your calculator will give you, and you add on 360n. So if we add 360 then to 30, okay, so if we add 360 and 30, the next value will be 390. Now let's just take a look on the calculator and just confirm what I'm trying to get across to you. So if I do the sine of 390, you should realise I'm going to get 1/2. Okay, so you can see clearly that the next answer is 390, which is here. Now, these steps, if I add on another 360, so that would be 30 plus 720, I'll get 750 degrees. So again, I'll simply show you on my calculator. If we do sine 750, and we get a half. So this is giving me, this first part is giving me half of all the solutions possible. We've got to remember, however, that the secondary value will also, 360 degrees later, have another value. So we've got to have the secondary value plus 360n as well. So that will give me 150, then 150 plus 360, so this value up here, 150 and 360. We're going to do that, but I'm getting tired on a Friday afternoon, so let the calculator do the work. 510, and if I add 360 to that, I think I can manage that. 870. Now this will go on and on and on. In fact, we can go backwards with negatives if we place a minus value of n. So we'll go and just choose one of those values. So I said that sine 700 and so what have I put there? I'll just take that away. 870. So let's do the sine of 870 and check how well we do sound. And there you are, 0.5. So this isn't the way the textbook teaches the topic, but this will stand you in good stead for all trigonometry that you do in C2, C3 and C4. So if sine x equals s, where s is a ratio between 1 and minus 1, the general solution is the PV plus 360n, the SV plus 360n, where the PV plus the SV equal 180 degrees. Or they might equal, if we deal with negatives, the PV plus the SV will equal minus 180 degrees. We'll have a look at that in a moment. Now the thing I need to say is that you will find the PD from your calculator. Your calculator is programmed to find the value that's closest to 0. So let's do a negative one and work our way through that. So let's say that sine theta equals minus 0.3, and I want to find the solutions between 720 and minus 720. So, okay, so here's a graph. Sine's going to do that, and then that, and then it's going to go like that, and like that. In fact, I haven't quite drawn enough of it here, but you'll see it does that. So, so if I do sine theta equals minus 3, clear that away. So if we do sine minus 0.3, and we notice that, we get minus 17.46. Okay, so theta equals minus 17.46. Now if I add that to 180, actually that's not going to work, is it? That's just to 180 minus 17.46. That'll do it. 162.54. So it will be a negative equal minus 162.54. So what we found is the angles there and the angles here. Now we need to move on in steps of 360 to get other values. Now I've probably gone a bit too far here. I'm just going to change that to 360 and to minus 360. So if we put it into the formula, minus 17.46 plus 36n and minus 162.54 plus 360n. So if I make n 1 in the first, I'm going to get minus 17.46 plus 360, and that will take me to the solution there. So jump me on 360. Quickly do that on the calculator. So 360 subtract 17, and we end up with 342.54. Okay, so 342.4. If we use the bottom one and we do 360 minus 17.46, that's wrong actually, 360 minus 162.54, and we get 197. So we've got minus 162.54 plus 360 equals 197.46. So our solutions then are 342.54, 197.56, 17.46, and minus 162.54. And that's using what's called general formulas, right? The general formula for trigonometric equations. I'm going to show you now how we can further adapt that into a problem like this. Suppose sine 2 theta equals 1 over root 2. Now, you can do this using a calculator, but you should know that the 1 over root 2 comes from the 45-degree angle triangle, where you basically, it's an isosceles triangle, where two sides are over 1, and the square root and the hypotenuse is 1 over root 2. So if we go back to my so that gives me the principal values. The principal value, therefore, is going to equal 45 degrees. The secondary value is going to equal 135 degrees. I haven't specified the range, so let's just say I want the answers between 360 and more. That's very commonly asked for. Okay, if I put my plus 360n on, plus 360n, and I'll use these formulas. I'll take one at a time. So my first answer then will be that 2 theta equals 45 degrees plus 360n. So to find out the value of theta, I divide through by 2. 180. And I will get two solutions from this. I'll get 22.5, and that comes when you make n 0. That will make this disappear. If you make n equal 1, you're going to get 202.5. So that was n equals 0, and that was n equals 1. If I add another 180 on, I will go outside of the range. I've got two more solutions, so I've got to do 2 theta equals 135 degrees plus 360n. So theta will equal 62.5, that's 67.5, that's half of 135, plus 180n. So again, if n is 0, we'll get 67.5, and if n is 1, get 67.5 plus 180, and that gives me 247.5. So if I list all the solutions then, take them in order: 22.5, 67.5, 202.5, and 247.5. Once again, this general formula is very helpful, and if we've got a double angle, we can just divide through and use the formula as before till we've got all the answers in the range given. Alright, so I'll do another video, I won't make this video any longer, I'll do another video showing you how to deal with cosine and tan.